This is Algebra 2 with Trig, Unit 2B.7, talking about rational zero theorem. In previous lessons, we have talked about how can we find the zeros of a polynomial if they give us a factor, or if they give us a zero. But what if we don't know the zero, or what if we don't know the factor of the polynomial function? What do we do if we don't have that information? Where do we start looking for what to use, or what possible zeros are usable? So we're going to look at the rational zero theorem. And this refers to the factors of the constant over the factors of the leading coefficient. So, with that in mind, we're going to look for the possible zeros of our polynomial. So we'll look for our possible zeros. That is going to be factors of 6, which is your constant, over factors of your leading coefficient, which is just 1. So this is going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Because all of these numbers go into 6. That makes them all factors of 6. Now theoretically we would divide those by 1, because those are dividing by the leading coefficient, or actually the factors of the leading coefficient, which there's only 1 for that factor. But when we divide by 1, it doesn't change the answer, so it's just these 4, actually 8, plus or minus, answers. These are the possible zeros. Doesn't mean these are all the real zeros. These are the possible zeros. When we think about possible zeros, any number is possibly one that could divide into that. But is there a way to narrow it down? Is there a way? Any number, there's too many numbers. So can we narrow it down to find out which are the best choices? Is there any mathematical way to do that? And that's what we're doing here, looking at factors of 10 divided by factors of 2. So the factors of 10, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Those are all the factors of 10. Now the factors of 2, 1 is a factor of 2, but that doesn't change the result. And 2 is a factor of 2. So we need to do another column, or row, I guess. 1 divided by 2. 2 divided by 2 is already written, so we don't need to do that. 5 divided by 2. And then 10 divided by 2 is already written. So these would be all the possible zeros. These would be your best choice in terms of numbers to try to figure out what goes into this polynomial. Alright, these are possible zeros. They aren't guaranteed to be the actual zero. Okay, how are we going to figure out which ones of these work? We're going to take synthetic division, use synthetic division to identify which values have a remainder of 0. We're trying to determine which of these numbers used in synthetic division is going to give us a remainder of 0. And when that happens, then we have a real 0. So we're going to try it. We're going to look for the real zeros. Well, first of all, we might want to consider, is this going to be able to use factor by grouping? Could we use factor by grouping with this? So we first consider, because this is what we've learned about with cubics before, these have 4 parts. So we try factor by grouping. That's the first way we would attempt it. Bring down your sign. Factor out what you can. A 3 goes into both of those. So we get 5x. Negative 3 times negative 6 gives us positive 18. So that would be factor by grouping, but notice these are different. So grouping cannot factor this polynomial. We can't use factoring for this polynomial because we got different, we don't have a common factor coming out of each one of these groups. They're different. So there is no common factor. So typically we would think, well, it can't be factored. But we're going to first look at possible zeros. The possible zeros are plus or minus 1, plus or minus 2, 3, 6, 9, and 18. Those are all the possible zeros. Factors of the constant number divided by the factors of 1. So it's just these numbers over 1, which makes it these numbers. So there's different ways to go now. So I'm suggesting that you pick one of those. I would suggest start with 1. Always start with 1. And we'll take our leading coefficients and we'll use synthetic to drop down 1 and multiply. And multiply. And look at what we get. We get 0. And we're happy to get 0, so we have a little smiley face. We have 0. So x, not plus 1, but x minus 1 is a factor. Because 1 is the 0. If you were to take this and equal it to 0, then you would have 1. 1 makes this a 0. So that's what we're testing, and we actually got the 0 to come. So x minus 1 is our factor. And then that leaves us, since we started with a cubic, this is going to make a quadratic. X squared with a 1 in front, x with a negative 3 in front, and a negative 18. So these are the two factors that are making up this problem. So this is a quadratic now. Hopefully we can factor that. So what two numbers multiply to be x squared? Those would be x. What two numbers multiply to be 18? That would be 6 and 3. 9 and 2 multiply to be 18, but 9 and 2 can't make 3. 6 and 3 with a negative 6 and a positive 3, those would add to become negative 3x. And negative and a positive make a negative for 18. So that's going to give us x minus 1 equals 0. That's 1, 0. X minus 6 equals 0. That gives us another 0. And x plus 3 equals 0. That gives us 3 different zeros. So let's go on and try it for our next problem. How about you pause the video, figure out what your possible zeros are, and then try them. If the first one doesn't give you 0, move on to another one. These are the possible zeros. Factors of 14 divided by factors of 1. Those are the only numbers that go into 14. So those are the factors of 14. So I would start with 1. Seems like a logical place to start. Don't make it really big. Try to make it small so that if you got extra ones that you have to do, you have plenty of room. Multiply and multiply. And here I add them and I do not get 0. Okay? Not 0. So x minus 1, remember it's the opposite, x minus 1 is not a factor. So let's try the next one. So we use 1, negative 8, 5, and 14. Drop it down and multiply. Multiply. And multiply. Oh, look at that. We got 0. 0. So x plus 1 is a factor. So if x plus 1 is a factor, and x squared minus 9x plus 14 is the other factor, which can be factored apart, we hope. So we're going to have x and x, multiply those two together to make x squared. Two numbers that multiply to be 14 but add to be 9, that would be 7 and 2. They'd both have to be negative to add to be negative 9 and multiply to be positive 14. So we use the zero product property and we get our 3 zeros. Now this was a cubic equation. A cubic equation is going to have a possibly 3 zeros. We should always be able to account for 3 zeros. Sometimes it might be imaginary, but we should be able to account for 3. Over here on the first one, it was a cubic, and we got 3 zeros. So let's come down here to this one. The possible zeros. Plus or minus 1. We're looking for 35. So plus or minus 1, plus or minus 5, 7, and 35, all divided by 1. So that doesn't make any additional ones. So we'll start out with 1. We use our coefficients, 1, negative 5, 7, negative 35. Drop it down and multiply. And that did not give us 0. So we'll try again. We'll try negative 1. Start out with our original coefficients. Drop them down and multiply. That gives us negative 48. Neither one of these, or 0, neither one of these turned out to be a factor. So following our possible zeros, we've done plus or minus 1, now we can try 5. So we use our coefficients. We bring down the 5, or bring down the 1 to multiply with the 5. Gives us 0. 5 times 0 is 0. Add them. Multiply. There it is. Knew it had to happen. Okay. We got 0. So x minus 5 is a factor. So we have x minus 5, and we have x squared plus 0 x's plus 7. Well, that's not factorable. Nothing multiplies to be 7 and adds to be 0. So we could use quadratic formula. Quadratic formula would help us calculate that out. But another way we can write it, we don't need to write it with 0 x's. So by looking at the zero product property, we would subtract the 7 to the other side. We would take the square root, and when you take the square root of a negative 7, you actually get plus or minus I root 7, because the I happens because of the negative inside the radical. That's the imaginary value, because you can't actually take the square root. Over here, the only real 0 apparently is at 5. So another way we could look at this is to plug it into our graphing calculator. So I typed in our problem for C into our graphing calculator, and I graph it out, and you can see at least it's crossing over here at 1, 2, 3, 4, 5. If we look farther down, we might see where the rest of this graph is. So we'll just kind of guess and check our way through this a little bit. We'll look down here at like negative 50. Yep, just 50. And we'll see that we have some curving going on. This is the cubic part of the graph. Alright, that's what a cubic does. It has some curving in the middle. It has 2 turning points. But because these maximums and minimums, local max and mins, are not intersecting with the x-axis, it only has one intersection. That's why we only got one answer. The imaginary value is what's happening here. Okay? So zoom number 6, we'll take it back to the normal graph. if we move down to our last question, if when we're working through the problem and we don't end up with a quadratic, we can work with the graph to find other zeros. So I'll show you what that means. When you have a quadratic, you can factor it. If you can't factor it, you don't have to give up. You can use the quadratic formula. So we look here at this problem, and we notice the possible zeros are factors of 42 divided by factors of 2. The leading coefficient is 2. The constant is 42. So we're going to have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 7, and don't forget 6 if we like to go in order. I was about to say that what makes 42? 6 times 7 makes 42. And 6 is made up of 2 times 3. So these are your only two factors that are going to produce additional numbers. So 2 and 3 make the 6, the 7. 2 and 7 would represent 14. 7 and 3 would represent 21. So if you're having troubles recognizing what the possible zeros are, or what the factors are of 42, you can kind of create them as you go by looking at the prime factors. Okay, so there are your factors of 42. All divided by 1 would be one set, and divided by 2 is another set. So plus or minus 1 divided by 2. 2 over 2 we already know. 3 over 2. 6 over 2 we already know. 7 over 2. 14 over 2 we already know. And 21 over 2. Wow, that's a lot of possible zeros that we have to go into this polynomial. So where do we start? Well, we'll probably start at 1. And you try 1, and then you try negative 1, and then 2, and negative 2, and you'd keep going. Or, if you like your technology, this was the old problem, but we're doing 2x to the 4th plus 5x cubed minus 18x squared minus 19x plus 42. That's the crazy equation. So get that typed into your calculator. Pause it if you need to. And when we look at the graph, we see that it does some curving in here all over the place. Okay, it goes up for a while, it comes back down. We don't really need to know what those spots are. It doesn't really matter. If you like to play with the window a little bit, you could look up, you could start with your table. Right, it looks like it gets up here near 42 or something. Looks like it goes down to 36. So we'll go a maximum of maybe 50 and a minimum of negative 50. Those seem to be two good heights to have it flow through. Now you can kind of see what's happening with the graph. It crosses, it's hard to tell here, but it does cross right there. We might put it back to the other view so we can see better. So we'll hit zoom number 6, and that takes us back to our normal standard of 10 dots on each axis. Now we can see what those are. By looking at our table, we can see that -2 is a great choice to use. -2 gives us a 0. We can see that on the graph. So let's start with -2 as a possible option. So we put in our coefficients, 2, 5, -18, -19, and 42. Drop down your 2 and multiply, 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 and multiply. And look at that. We use the calculator to help narrow it down. Now some people are going to ask, if you use the calculator and you knew that was a 0, why did we have to do this? Well, we're trying to use synthetic division to help support. We're just using the calculator to shorten up the amount of work that we need to do here. We got a 0. So x plus 2 is a factor. So if x plus 2 is a factor, this started out as a quartic. Now we're going into a cubic. This is 2x cubed plus x squared minus 20x plus 21. Wait, this is cubic. I can't factor that. Factor by grouping doesn't work. I pull out an x squared, I get a 2 and a 1 left over. There's nothing to pull out of here, so I got a 20 and a 21 left. They're not the same factors. So I have to do it again. So you could either make a new list of possible zeros, but you don't even have to do that. You could type in your new equation. You don't even have to do that. You only have to look at the one that you already have. Now you want to look in your table for other zeros, but unfortunately there are no other zeros that are being shown. Okay, so there's no other integer values. So another way we can do it is to hit second 0 or second calc. We use our 0 button. And I'm going to look for this spot right here. Alright, so I need to be to the left of it and hit enter. I need to be to the right of it and hit enter. So I'm to the left and to the right. So it gives me this crazy decimal for what that 0 is. Well, that's not going to help me in terms of my factors. That's not going to give me an option. So that's out. I could try to look at a different one. Go to 0. We knew this one doesn't work. This one, I'm going to try that. It's going to be tough to get to. So we scroll down, we scroll back up, start to come down. There it is. So we hit enter to be on the left. Now we're below it. And we hit enter. And we got 1.5. Wait a minute. 1.5 is 3 over 2. 3 over 2 would be a good option. And we would use these as our coefficients, not the original. 2, 1, -20, and 21. Drop down your 2. Multiply. How you multiply a fraction times a number is multiply the tops. So 3 times 2 is 6. Divided by 2 is 3. Add them together. 4 times 3 is 12. Divided by 2 is 6. -14. 14 times 3 is 42. Divided by 2 would give you 21, and that would be a -21. And look at that. Alright, well, we knew it. We used our calculator to help verify that, but we used our synthetic to help kind of like prove it or represent our work. So we didn't just have to guess through all the numbers. So now we're working through, we have x plus 2 as a factor. We have this 3 over 2, like x minus 3 over 2. Well, if we were to try to solve that, we'd get our 0 as 3 over 2. Multiply by the 2, subtract the 3 across, and that's a better looking factor. So we have 2x minus 3. When we added the 3 and divided by the 2, you'd get your 3 halves. And then the previous problem was a cubic, so now we're at a quadratic. So this is 2x squared plus 4x minus 14. Alright, so we're working our way through. First we had a fourth power, then we had a third power, now we have a second power. Now if this is factorable, we could factor it. We look at the different factors here. Can you multiply to be 28 and add to be 4? We know that the largest number would have to be positive and the smaller number would be negative. But no, nothing is going to multiply to be 28 and add to be 4. So this is not factorable. No fear, try the quadratic formula. Remember the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac, everything over 2a. So my b value is 4, so I get negative 4 because it's negative the b plus or minus b squared minus 4ac all over 2 times a. (16). Two negatives make a positive, and that's 112. That's going to give me negative 4 plus or minus 128. Well, 128, that is 64 times 2. And 64 you can take the square root of, so that's 8 root 2 over 4. Now because 4 goes into both sides of the plus or minus, it has to go into both, you get negative 1, because 4 goes into negative 4 once, and it goes into 8 twice. So that is actually two of your answers. X equals negative 2 is another answer, and we know that x over 3 over 2 is the fourth answer, because this was originally a quartic. It was a fourth degree, so we knew that there were 4 possible zeros, and when we looked into our graph we saw that there were 4 zeros. And remember this one back here, this 0, move to the left, move the cursor to your left bound, and now right bound, one more actually. So this is going to give us this negative 3.828. Well, if you wanted to test it out, you could take your negative 1 minus 2 root 2, and you should get that exact same decimal. Alright, so that, you can't take the decimal to get this result, but you can take this result to get the decimal. We don't want the decimal. We're just testing to show you what that meant here. This was negative 3.828. So those are your 4 different answers. So in review, what did we just do? That was insane. We had a quartic. We figured out the possible zeros. we could try possible zeros. Instead, we used our calculator to look in the table for what a possible zero would be. There's -2. That helped narrow it down so we didn't have to guess. So we used -2 to show that that worked. We used the quotient to help us figure out the other factor, and we did it again. And we did it again, and we were stuck here with this quadratic, so we used the quadratic formula. Good luck, everybody.